So you have a curve C is given by this equation. 3x squared minus 2xy plus 8y equals 0. Find dy dx. So this is implicit derivative. A part 1, this is B1. So that's 6x minus, now here you need to be careful, you need the product rule. 2 times y plus 2x times dy dx plus 8 dy dx equals 0. So just be careful. Here this is a product. You're multiplying two things together. So first I did the derivative of 2x, which is 2, and then I did derivative of y, which is dy dx. So I have 6x minus 2y minus 2x dy dx plus 8 dy dx equals 0. So 2x dy dx plus 8 dy dx equals 2y minus 6x. So I have 2x plus 8 dy dx equals 2y minus 6x. So I have dy dx equals 2y minus 6x over 2x plus 8. Now I can cancel a 2 and everything and I get my answer. Dy dx equals y minus 3x over x plus 4. So that answers the first part. Okay. Next, show that this has a turning point when y equals 3x. Do you remember what a turning point is? What's a turning point? Does anybody remember it?
I think the turning point is like when you substitute, I don't know how to explain it, but I think you substitute the value into the equation.
No, not quite that. There's something dy dx should be when it's a turning point. 0. So that means y minus 3x over x plus 4 should equal 0. So therefore, y should equal 3x and x not equal to minus 4. So that takes care of part 2. Part 3 is now to find this turning point. Now in part 3, what has happened, you need to find x and y. So you have two equations for x and y. You have this one here and the one at the very beginning. So this is now one of these one linear and one quadratic problems. You have 3x squared minus 2xy plus 8y equals 0, and you have y equals 3x. So you just take that and sub it in there for y. 3x squared minus 2xy plus 8y equals 0. 3x squared minus 6x squared plus 24x equals 0. So minus 3x squared plus 24x equals 0. So 3x squared minus 24x equals 0. I should divide by 3. X squared minus 8x equals 0. And here I get x and x minus 8 equal 0. So you have x equals 0 or x equals 8. And you need to find the y, and you can find the y by using this formula. Y is equal to 3x. So if you just sub that back in, you get y equals 3x, so 0, or y equals, no, that's right, 3 times 8, 24. So your first answer is 0, 0, or 8, 24. They're the two coordinates of the turning points. I suppose we could draw that to see those turning points. Yeah, I substitute x equals 0 and 8 into the formula y equals 3x. Okay, let's have a look at that graph. Oh, it's not loaded yet. Here we go. Let's have a look at this graph. Okay, so we have here 3x squared minus 2xy plus 8y equals 0. Now, what did we say the two turning points were? Like 0, 0 was one of them, wasn't it? So you can see, I know it doesn't look right here, but it looks pretty flat there, doesn't it? That's 0, 0. And the other turning point, oh, it's going to be somewhere like here. Look, there's pretty flat there. And about, yeah, 8, 24 looks about right. So yeah, these answers look good. Okay, let's have a look at the B part now.
Sorry,
Yeah.
Can I just ask a question that is related to math but not on the past question? It's
Sure. After this, or is it related to this topic?
It's not related to this topic, it's differentiation.
Okay. How about after I finish this, we can have a look. Is it
Yeah.
from the book?
It's from this past question, but it's not exactly a question.
Okay. Well, yes, we'll look at it now in a minute. So B here, 1, x cubed minus 100. You want to show that it has a root somewhere between 4.6 and 4.7. So on your do you remember how to do this on your calculator? What you have to do is put in the two values. One should be positive and one should be negative. So you put in 4.6 cubed minus 100, and then you tell me what you get there, please. And then you put in 4.7. So that's 4.7 cubed minus 100. Yeah. Yeah. So, since fx changes sign, that means there's a root somewhere between 4.6 and 4.7. Newton-Raphson,
Because of this positive.
then there's a problem. It should be one positive, one negative. And if they ask you to do this, it should be that. My advice would be, if that's happened and there was a sign or a cost in it, maybe you're not in radian mode. Okay, the next part is they want you to use the Newton-Raphson formula here. But what's great is you don't even need to work out the formula. In this question, they actually give it to you. They say xn plus 1 equals a half xn plus 100 divided by xn squared. This is just like recursive sequences you did in semester 1. They tell you where to start. They say start with x0 equals 4.6. So maybe, Sunita, you could type this formula in on your calculator, but put x is 4.6. So it's a half bracket 4.6 plus 100 over 4.6 squared. And then Grace, if you could do the same, if you have a calculator, we'll make sure we get the same answer. Yeah, give me all the decimal places. 4.66294. Okay, so now you have to do it for x2. So you take this answer and you put that back in to get x2. Now, if you still have your answer on your screen, you can just type the answer button instead of typing it again. You don't think that's right?
Oh, yeah, she's right.
Yeah. Okay, so if the two of you can give me the next one when you're ready. Are you have it? What is it? I think you did something went wrong there. It shouldn't change that much. No? Yeah. You just forgot the square at the end. So you get 4.63105531. Okay, and then last one. I got 4.6468915558. And there you go. Yes.
I keep picking answer.
Yes.
So I can make it reoccur, but it doesn't give me the next one. Like,
it gives you the same one.
It gives you the same one.
That means you're not doing it right on the calculator. Let's see how much you're typed in.
So I have to retype.
Yeah, but you need to have the number, like, what's the start with, 4.6?
Yeah.
You have to do 4.6 equals and then clear it, and then type in the formula with A and S instead of the number. So like you have a half times bracket A and S instead of X. Like this. And then you can continue with it. Okay, there you go, thank you. Alright, so that's one. So what was your question then, Grace, that you had?